Okay, we're on to the next page. Page 3 is called Parts of a Parabola. That word is a parabola. Some people call it 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 a curve. But as long as you call it something about a parabola, then that's what you call the graph of a quadratic. Because the shape a quadratic equation makes is called a parabola or parabola. Take your pick. Okay, let's start off by labeling the little pieces of it. We have these two things, which are right here and right here. And if you pay attention to where those are, they are on the x-axis. Those little spots are where the curve is intersecting the x-axis. So we're going to call that the x-intercept. But you also know that x-intercepts have different words for those, and those other words are roots. Okay, we got an arrow pointing right here. That is where it's touching the y-axis, and where a line touches the y-axis is called a y-intercept. And there is no other word besides the y-intercept. Something that you could notice, though, is that this number right here, if you count it, it's at 1, 2, 3. And in the equation right here, this actually tells you what the y-intercept is going to be. So the standard form quadratic equation, y equals ax squared plus bx plus c. C is going to tell you what the y-intercept is. Down here we have an arrow pointing. It's a little off, but it's pointing right here. That little bottom piece is called, well, for one thing, it's the bottom of the graph. Since that's the bottom of the parabola, then that's going to be the minimum. Every single time you have a parabola that opens, like it opens upwards, it's pointing with its arrows up. If that happens, then it's going to have a minimum. And a graph will always open upwards if A is positive. If that's positive, then your graph is going to open upwards and you're going to have a minimum. I'll show you that. I'll show you more examples of that later, though. What this little piece is called, even if it was a graph going like this little piece right in the middle of the parabola, that's always called the vertex. The vertex is going to be where the maximum is or where the minimum is, and it's going to be an ordered pair. And that ordered pair is going to be called h, k. And those numbers are really just going to be an x, y. It's an x and a y. It's whatever's at the coordinate. So let's get this actual coordinate here. This is at -2 for x and -1 for y. That's the vertex of this parabola. And here we have an axis. Oh, okay, so that's what I'm supposed to put here. One of the roots for the x-intercepts, the value of this spot is that x is equal to -3, and the other value is x is equal to -1. Those are the roots. Those are the x-intercepts of this graph. The y-intercept was y equals 3, or I guess better way to label these would have been if it was 0, 3, and this would be -1, 0, -3, 0. I mean, I would be okay with it just saying x equals -1 or x equals -3, but on a test, you might see it as an ordered pair also, like you used to see it in the past in this class. All right, this line going up and down straight through the middle, it's cutting it in half, but notice it's a dashed line. That's because that line isn't actually there. It's just to show you that that is an axis where the graph is symmetrical. We call it the axis of symmetry. Symmetry has two m's. Let's do another example with a different type of equation. In this equation, if you notice, it has this thing with the parentheses and this thing outside the parentheses, and that's going to be vertex form. Whereas this other one was in standard form. In vertex form, this number on the outside, that's not the y-intercept. Let me just write down the equation for vertex form. Y equals a x minus h squared plus k. And notice that there's a minus sign right here for h. So that means that this -1 is not the actual value of h. H is just 1. And that makes sense because if we look at this spot right here, which is the vertex, the x for that is 1, and the y for that is 2. And the 1 matches with this 1. It's only negative because it's negative in the formula. And the 2 matches with this 2. So if you have vertex form, it's really telling you exactly where the vertex of the quadratic is. This dashed line is the axis of symmetry. When all you have to do to find the axis of symmetry is you just look where is the middle of the parabola, or you look where is the vertex at. The vertex happens when x is equal to 1, so the axis of symmetry is at x equals 1. The axis of symmetry in this class is always going to be x equals something, and eventually later in this book I'll tell you the formula for it. Let's label a couple more things, and those are going to be the roots. Let's label this point. This point is at -1, 0, and that's the x-intercept. But then there's also another x-intercept, and this one is at 3, 0. It's pretty common for parabolas to have 2 x-intercepts, and they only have 1 y-intercept, which shows that, look, whenever you have vertex form, it's not very common that you'll have to find the y-intercept. Like, we can kind of guess that maybe that's a 1/2, but since this is a curve, that wouldn't be a good guess to make. The most important points to get from any parabola is going to be the vertex, which is at the top, and the roots, which are the x-intercepts.